In this episode, we'll talk about these 3D printed flip-flops, but it's about more than footwear. These shoes tell the story of the future of manufacturing. Welcome to the Cool Parts Show.
Season 3 of the Cool Parts Show is brought to you by Carpenter Additive. The company's Athens, Alabama Emerging Technology Center is an end-to-end additive manufacturing production facility with everything from material development to post-processing under one roof, ready to help you with your next metal 3D printing job. Check them out at carpenteradditive.com. Now back to the show. I'm Pete.
I'm Stephanie.
We are with AdditiveManufacturing.media.
And this is the Cool Parts Show, our series all about cool, unique, and awesome 3D printed parts.
We are at the end of Season 3. We've seen lots of awesome 3D printed parts. And Stephanie, you've got a big cylinder in front of you.
Yeah, so this contains our last cool part of the season. So we are social distancing right now, so I'm just going to toss you one of these.
Hit me. All right.
This is our season finale. What do you think?
Like it? I'll say we've done footwear already, right?
Yes, we have done footwear before, but we are going to do it in a different way today. So do you remember at the beginning of this year, the beginning of 2020, you walked in my office and you gave me an assignment for the year?
Yeah, I do. So you were just about to start work with one of our sister brands on an article that had to do with recycling, sustainability. Sustainability, a promise of additive manufacturing that up till then we hadn't really looked at in a really focused way. And you ran with that. And in fact, you ran so far with that, ultimately we were able to put out an issue of the magazine entirely devoted to sustainability, the circular economy.
Right, and so in working on that assignment, I really quickly learned that sustainability is a lot more than recycling. There's this whole idea of the circular economy that you just mentioned, which is this idea that we should take our resources and use them responsibly, keep them in play for as long as possible, and then when something wears out, you should recapture that material and feed it back into the cycle. And so we're going to talk about these shoes today because they are an example of that. This is the circular economy, a closed loop from beginning to end. And it's not just about manufacturing, so the implication here is that we don't have to stop buying and making new goods. We can keep consuming, but we have to be more conscious of what happens to products at the end of their life cycle.
Okay, so I'm with you. Tell me about these flip-flops. Tell me how they close the loop.
Okay, so these are custom 3D printed flip-flops. They're made with an FDM process, fused deposition modeling. They are produced by a company called Retraction Footwear that's in Australia. So the founder, his name is Brett Kaysen. He is an engineer, actually was working in the construction industry, but he got into 3D printing as a hobby. And I'll let him explain why he started a footwear company.
Yeah, well, I started Retraction Footwear mainly because I've always loved making things and solving interesting problems. It struck me that additive manufacturing has one of its real strengths is its ability to customize. I think nowhere is that more important than when the human body is involved. So the more I thought about it, the more it seemed crazy that everyone's got different feet, but we're forced to choose from maybe a dozen standard different sizes. So I've always worn flip-flops or thongs, as we call them in Australia. And while I love their simplicity and their convenience, the fact is they're not great for your feet. Starting a 3D printing company with making flip-flops combined two of the things that I loved and gave me the opportunity to make something that I thought would be significantly better than what was currently available.
So Stephanie, I think you're wearing Australian 3D printed flip-flops right now.
I am indeed, yes.
Okay, so then you probably have an opinion about all of this. I confess I haven't thought about flip-flops in that way before, so you elaborate. What are the problems with flip-flops?
Well, so there's a couple of problems, but I think kind of the big one here is the issue of size. So we all kind of walk around with this number in our head of what our shoe size is, but it's not exactly accurate. So like for instance, my feet are a 7.5-ish. If I'm buying something where I know I'm going to wear socks or something, you know, sometimes I go up to an 8. If I'm buying a sandal like this, I might go down to a 7. And you just don't actually have that many choices. You know, there are these 12 or so standard sizes and you can sort of choose between them. Maybe you get the option of a wide or a narrow, but it's often a compromise when you're shoe shopping. And it's often the case that you encounter some shoes that you have to leave on the shelf. They're just never going to work for you in any size or configuration that's available.
So I'm listening, and you're talking about sizing, and again, we've done the issue of mass customization, specifically focused on footwear, and you wouldn't be taking us here again if there wasn't more to say about it or something different to say about it here. So play that out a little bit more. Take us there.
Right, so we've been talking about size, but size is not equivalent to fit. Size is really just expressing the length of the shoe, right? And then there are all these other factors that actually go into how the shoe fits you. So for retraction, it's not a scan process like what we've talked about previously. It could be one day, that's something they're interested in. But right now, it's a series of drop-down menus when you order these shoes. And so you have the choice of size, of length, but you also have different widths that are laid out in centimeter measurements. So you have a much better idea of what size shoe you're getting. You also have the option of different supports based on whether you have high arches, flat feet, kind of average. You can put in your weight, and that also influences the support. And you get to choose the colors. You get to choose the strap and the footbed and the sole on the bottom.
Drop-down menus with lots of options. Why can't we have that today? Why can't today's flip-flops give us that kind of variety?
So I'm glad you asked. So if you think about a standard flip-flop, it's a piece of foam and a plastic strap. This foam would be cut with a die cutter out of a larger piece of material. The strap would be injection molded. And so for both of those processes, you need tooling. And if you're going to make the investment in tooling, you want to buy as few tools as possible and just make a whole bunch of parts that way. So we're locked into these standard sizes, again, because of tooling.
And I know that there's a macroeconomic issue to all of this, and you want to take us there, and I want to go there. But I'm really not done with the flip-flops yet, okay? So these are 3D printed, and we know something about 3D printing is you're controlling geometry outside and in. Let's talk about in. What's happening? If I cut this open, what would I find?
Yeah, so depending on how you answer the weight range question and the arch support question, the inside of your shoe is going to look different. So here's Brett describing what happens on the inside.
You can see the amount of cushioning and air pockets within it. These air pockets, we can customize the amount of, or the size of them to suit the wearer's foot size and their weight. To give an optimal mixture of cushioning and support. Adjusting the amount of support inside an item of footwear is a pretty revolutionary concept, especially in a thong or a flip-flop, but it's something that we think is important to maximise user comfort.
All right, so I think we're ready now. Why don't you go global? You kind of connected this to the circular economy. How is this flip-flop the future of manufacturing?
Okay, so if you think about how flip-flops are typically made, this is 2 different materials, probably made in a large factory, probably assembled together by hand. And this is the classic linear economy. You know, we take resources, we turn them into products, we sell those products, and then at the end of their life, they get thrown away. So there's like a clear beginning and end. And then when you look at what retraction is doing, it looks much different. So starting first off with the material. So this shoe is flexible TPU, and the whole thing is the same material. So right off the bat, this is easier to recycle because you wouldn't have to separate anything, any part of it out. It's made specifically for the user, so it's made not just to the size of the wearer, it's made to fit them exactly. And so these are made on demand. They don't produce any extra shoes, and so you don't have issues with inventory. You don't have any extra stock that's going to get thrown away when the season changes or when styles change. And the manufacturing process itself is more sustainable. So you have, instead of a big factory, Retraction is able to make these with just a dozen desktop printers, so much smaller facility, and it's a more energy efficient process. So they've actually optimized their printers so that each one only uses about the same amount of electricity as a light bulb. These are printed without support structures, so you don't have that waste in the process. You're not trimming anything off. And just for comparison, these are both my shoes, but the conventional one has so much extra material, and so like you're even eliminating the waste in the end product itself. But we've been talking about this whole issue of the circular economy, and these shoes from Retraction, they close that loop, because when you are done with this shoe or something happens to it, you can actually ship it back to Retraction Footwear, and they will grind it up, turn it into filament, and make new shoes out of it.
Okay, so I get it. I'm there with you, and I see why this shoe is so important and why it's worth going back and doing footwear again. Because in Additive Manufacturing.media, we've looked at these issues, but we always get the chance to do just one of these issues at a time, right? We talked about products that are made to be more efficient, or we talked about different modes of manufacturing and different types of factories that are more eco-friendly, or we've talked about recycled material, but it's always just one piece or another. Here's maybe the first product, and maybe the first of many products to come, that's an example of putting all those pieces together, the entire loop.
Yeah, so when you gave me that assignment at the beginning of the year, like, this is a story I've been looking for. I was so excited when Brett reached out because, you know, this looks like kind of a simple part, but it represents so much about manufacturing. And I think there's one other aspect about this that we should address.
One of the major issues facing the footwear industry is waste. It's estimated around 20 billion pairs of footwear are made every year using traditional methods, and traditional methods are a subtractive process. So you end up with offcuts. It's estimated that can be up to around 15% of the total material used, which, when you sort of extrapolate it out, can end up to quite a lot. 3D printing is an additive manufacturing process, so we're only using the material where it's needed, meaning no waste. Another real benefit that we have is that traditionally footwear companies offshore their manufacturing, which means they sort of need to do things in large runs.
So when you stop thinking about shoes as this kind of 12 standard sizes made from larger pieces of material in large factories, and you start thinking about them as more digital custom products, you can change, you know, how the supply chain works. So instead of centralized factories that are producing shoes and shipping them all over the world, if you're 3D printing these, can you put 3D printers in different parts of the world? You know, we saw that kind of with the coronavirus pandemic, that it was difficult to get goods from different places. And a model like this, where you just need a desktop printer, could result in shorter, much more reliant supply chains.
Okay, so that's a lot. Okay, so I'm in. Like, this flip-flop has a lot to say and a lot to teach us. Okay, so let me see if I've got all this. 3D printed flip-flop. So this is made not literally customized to every individual, but with so many options in sizing and selecting it that you can get exactly the flip-flop that you want. This manufacturing process allows the chance to wait until the consumer actually orders it to produce as needed, produce in precisely the quantity required, because the end user tells you what quantity they want. So then, in addition to that, it's an energy efficient production process. Very low footprint manufacturing equipment. These 3D printers that fit on a desktop take up very little space, very tiny factories, and just adapted even to be more energy efficient still. I think you said that just the energy output of a light bulb is what each of these 3D printers requires. And then where they're going next is completely closing the loop, because Retraction Footwear has a plan to accept back flip-flops that the user is all done with, so that they can be ground up, reclaimed, used in brand new flip-flops produced later. Completely closing the loop in the circular economy. So what this shoe shows is sustainability at all the steps of how you think about a product. Sustainable design, sustainable production quantities, sustainable production hardware, and a sustainable strategy for end of life.
Thank you for watching Season 3 of The Cool Parts Show. We're going to go on hiatus for a little bit, but we'll have some other special episodes coming to you in the meantime. Make sure you're subscribed so you don't miss any of our new content.
If you're new, if you're seeing this for the first time, we'll be back. But in the meantime, go watch all of our existing stuff. Season 1, Season 2, special episodes, thecoolpartsshow.com. Thanks for watching. Thank you to our sponsor, Carpenter Additive. Listen to additive manufacturing podcasts, attend webinars, and learn more at carpenteradditive.com.